This practice exercise is concerned on solving problems that involves measurements of angles in a polygon, specifically the interior angles in a polygon. So we have here three items, and we are going to solve the sum of the interior angles of an undecagon, the measure of each of the interior angles of a regular heptagon, and if we are given with an interior angle of a regular polygon, we are going to determine what type of convex polygon are we talking about. So to answer number one, let us try to determine the sum of the interior angles of an decagon. To do that, let us try first to determine the number of sides of the given polygon in number one, which is represented by the variable n. An decagon is actually a polygon with 11 sides. If you're confused with this and the next polygon with 12 sides, which is actually dodecagon, please consider this hint. If we say deca, that would actually be 10. So we are sure of it. And if you say an, that is actually a clipping of the term which corresponds to 1, which is actually uno. Right? It's a Spanish term, it's a Visayan term, a Filipino term, uno. If we say uno, that's 1. And then we have decagon, we have 10. So that's uno, decagon, that's 11. And if we talk about dodecagon, 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 okay, just to make sure of the differences, okay, decagon is 12, dos, okay, dos. So we have here 2. Okay? Another hint for that is uno, once. Okay? That's a term. Do, doce. That's also another term. Okay? I'm just giving you a differentiation of undecagon and the decagon. So you will not be confused later on. But that's not our main focus here. Our main focus for number one is determine the sum of the interior angles of an undecagon. The sum of the interior angles of an undecagon. To do that, we actually have a formula which corresponds to the sum of the interior angles of any polygon, which is actually represented by S, and is actually computed with the process of subtracting 2 from n and multiplying it to 180 degrees. If you are not yet convinced with this, you can always go back to our module because we actually use a pattern to determine the number or the sum of the interior angles of a polygon here. We started with a triangle, quadrilateral, pentagon, hexagon, so on and so forth, and we come up with this formula, or we came up with this formula. So to answer number one, simply substitute n, and you will have here 11 minus 2 times 100, sorry for that, 180 degrees. Okay? So we have here 11 minus 2 is equal to 9 times 180 degrees. 9 times 180 degrees is equal to 1620 degrees. This is now the answer for number one, which is actually concerned on the sum of the interior angles of an undecagon. Take note that our unit here is in degrees because we are talking about interior angles. And the unit of measurement for angles is again in terms of degrees. So this is the answer for number one. Let's proceed to number two. We will actually use the same concept here, but we just added another consideration. Here, we are now tasked to determine the measurement of each of the interior angles of a regular heptagon. Okay? So we are not anymore tasked to determine the sum of the interior angles, but we are going to determine about the measurement of each interior angle of a regular heptagon. We're still going to use the same formula because for us to determine the measurement of each, we need to determine the totality first. And we know that a heptagon is a 7 sided polygon. So let's complete it here with the formula. You have n minus 2 times 180 degrees, and you have here 7 minus 2 times 180 degrees. 7 minus 2 is 5 times 180 degrees. Okay, 180 degrees. And that is actually equal to 900. Sorry for the extension. Let me erase this one. You have 900 degrees. This is actually not yet the answer, but this is the sum of the interior angles of a regular heptagon. The next here is to determine the measurement of each of the interior angles there. I would like to highlight one important thing. In our given, we are told that it's a regular heptagon. And regular heptagon is an equilateral and at the same time equiangular polygon. If we say equiangular, all interior angles have the same measurement. So by looking at the claim that it's a regular heptagon, we can just simply divide it by the number of interior angles. But if there are no claim, let's say what is the measurement of each or what is the measure of each of the interior angles of a heptagon, we can actually determine that, because if we do not say regular, we don't know how what are the relationship of each interior angle to the other. But since we are given with a regular polygon, we just are simply going to divide this into 7. Why 7? Now let's use here the interior angles. There's a formula I have mentioned last time in our module. So we simply need to divide s by 7. Why 7? Because it's a heptagon. If it's a seven-sided polygon, that would mean it has 7 vertices and it also has 7 interior angles. Okay? And then we are just going to divide it. So we have 900, sorry for that, 900 degrees over 7. So the sum of the, not sum, sorry, for the measurement of each of the interior angles of a regular polygon is given to be, or let us just simply approximate this because this is cannot be actually divided properly. Approximation symbol, we will use we will use this symbol. Let's just simply round it off into 2 decimal places. The result is 128.57 degrees. So this is the measurement of each of the interior angle of a regular heptagon. It was made possible by first getting the sum of the interior angles of of a heptagon, and then by using the claim that it's a regular polygon, a regular heptagon specifically. If this claim, regular heptagon, is not there, we cannot proceed to the next. Let's proceed to number 3. We are now going to solve or determine the type of polygon if the measurement of an interior angle of that regular polygon is 150 degrees. So if you say regular polygon again, all of the interior angles have the same measurement. That would mean all of the interior angles is equal to or measures 150 degrees. To do that, let us look at the solution for number 2. We are just simply going to play it backwards. Okay? We are going to play it backwards. If we are going to combine the two steps in number 2, we are just simply going to make a formula in this manner. We have here the measurement of each interior angle is S, which is this formula here, n minus 2 times 180 degrees all over 7, which is actually the value of n as it's the number of side. So this is actually the formula for the measurement of each of the interior angle of a regular polygon. Why we are doing this is because this is what we are going to use to solve number 3. We are given that the measurement of the interior angle of a regular polygon is 150 degrees. So that's the value we are going to use here. 150 degrees is equal to, we don't know n, and that is actually the variable that we will be solving. For n later on will tell us the number of sides a polygon has and probably tell us what type of polygon it is. So we have this literal equation here. To solve for n, we are going to remove n here first by multiplying n here. So we could cancel that one. But property of equality tells us to do the same thing on the other side. So we have here the result, uh, green colored, 150 degrees n is equal to, don't have this anymore. So you have n minus 2 times 180 degrees. To continue, let's distribute this rather. By distributive property, we will get 150n is equal to 180n minus, that's 360 degrees. Okay, so it's a little bit longer than what it used to be because we are going to add 360 both sides here. Okay, so plus 360 degrees. So we will get 150 degrees n plus 360 degrees is equal to, that's 0, 180 degrees n. Again, our goal here is to solve for n. So we are going to remove this by subtracting both sides by 150 degrees n. Subtract 150 degrees n here as well, and you will get the value of 360 degrees is equal to, that's 180 minus 150 is 30 degrees n. Okay, we still have n because that's the item that we are going to solve. Finally, divide both sides by 30 degrees so that n will be left here. So our result, we have here n on this side. 360 degrees divided by 30 is 12. No more degrees because it will actually be canceled here. Okay? And at the same time, n means sides, and measurement of sides or number of sides do not have unit of n. So we have n, 12 is equal to n, or by symmetric property, n is equal to 12. Okay? So this is the result using the backward methods of number 2 to solve for the value of n. And what is that polygon with 12 sides? Okay, I have mentioned earlier, undecagon, unce, uno, that's 10 for deca, and uno, 1. Dodecagon is deca 10 and do or dos, doce. This is actually the name of a 12-sided polygon. The answer for number 3 is that it is a dodecagon. This is the answer for number 3. How, again, the process here was reversed. So, di ba, in mathematics, we do have different processes. We have subtraction for addition, division for multiplication. We have principal roots for principal for exponentiation. So we have the reverse method. So in this item, we are reversing number 2 to get number 3. If you would like to be convinced whether your number 3 answer is correct or not, you can always check using the process of number 1, right? So, and then and number 2. So we are and number 2 rather. and check using the processes stated in number 1 and number 2. So if we do have 12 sides, okay, let us try to target 150. Right? So we have S is equal to n minus 2 times 180 degrees. By the way, this is checking for number 3. So we have here 10 minus 2. I sorry, not 10. I'm sorry for that. 12 minus 2 times 180 degrees. So S means 10 times 180 degrees, which would actually be equal to 1,800 degrees. This is the sum of the interior angles of a dodecagon. And let us try to determine if it's a regular dodecagon. By the way, it should have a statement here that it's a regular. I forgot to place it here. Okay, a regular dodecagon. Okay. We're just simply going to divide, okay, 1,800 degrees by the number of sides 12 to get the measurement of each interior angle. And if you're going to do that, 1,800 divided by 12, we will actually get 150 degrees. And this is actually what is given for item number 3. So please review these methods and please be familiar with the formula so that later on you could actually make it easier, or not necessarily easier, but you are familiar with the processes so that you will not be too pressured with time. So please stay tuned for the next videos. This video is for the measurement of interior angles. See ya.